All right, hello, ladies and gentlemen. Today I'm going to be going over the worksheet that I handed out. I'll go over the answers pretty quickly. If you have any more questions, always feel free to email me. There's going to be a pretty quick solution guide. There's a lot of math in this one, and I don't think I need to show all of it, but I'll just kind of walk you through what we see. So, start off with in our first one. We have our gravitational force between two objects. So we're going to be using our new formula that we've been talking about. Drawing over here. Our force of gravity is equal to G m1 m2 divided by r squared. Now G is found on the reference table. It's that 6.67 times 10. I apologize for my handwriting. I guess I'm not the best at writing with this. Times 10 to the minus 11. The two masses are both 0.425 and the radius is 0.5. Now the key thing to keep in mind is that the radius is squared. That's one that people often forget. If you plug it all in correctly, you should be getting choice 2 as the answer. Okay, so question 2 and also question 4 both have a similar thing. They're using the same formula, but they use two different terms for what they're asking for, even if they're asking for the same thing. And that is the acceleration due to gravity and if we go down to 4, our gravitational field strength. Both of these are the same thing. Both of these are G. Our goal here is to find G using Fg over m. Now on Earth, G is simply 9.81, but on these other planets, planet X, and on a small planet, our G value is going to be different. Now it should be pretty straightforward. F of G is weight. That should be the newtons. So the 40 newtons goes here, divided by our 10 kilograms. And if we do that, we get our gravitational field strength, which is simply just 4, which is also choice 4. Question 3, sorry, skipped around a little too much. Question 3, we should hopefully narrow it down to choices 3 and 4 because as the distance between the planets gets greater, our force of gravity should get smaller. And it is choice 4 is the correct answer. It does have that kind of curved shape. Anytime that you divide it by the thing on the x-axis, it's going to be curved, whether it's squared or not. In this case, it is squared. All right, here we are back to our same formula. This vertical height does not matter. If you're anywhere close to the surface of the planet, you're going to have the same gravity. It's basically saying if things were dependent on height that closely, then 9.81 would not be our value anywhere on Earth. It would be changing quite a lot. It doesn't change quite a lot. You can be on Mount Everest. You still have 9.81 for your gravity. You have to go very, very far away from the Earth for it to start to change. Anyways, we have, again, our formula, G is equal to Fg over m. Again, we put the newtons on top, the kilograms on bottom, and we get our answer of 2 newtons per kilogram. So newtons per kilogram and meters per second squared are both the same unit, just written in two different ways. Acceleration due to gravity, gravitational field strength are again the same thing, just kind of two different terms that mean the same thing. It's mostly different because of how we use it. Acceleration due to gravity, of course, we'll be talking about accelerating objects much more. For gravitational field strength, you're generally going to be talking about weight, forces versus mass. An object moving in a constant speed circular path, centripetal acceleration is constant in. So the centripetal acceleration has the same magnitude to a constant speed. The acceleration is not changing. However, the direction is. For example, if I was to draw a circle, if the object's over here, the acceleration is pointed to the left. If the object is up here, the object is pointed down to the right. So it's magnitude only. The direction changes as it spins around, as it points towards the center. That's what centripetal means. Over here, these two are the magnetic field. That, of course, doesn't work out. We're just talking about gravitational around the Earth. No matter where you are, it simply points right towards the center. So I'm getting all these notifications. Calculate the magnitude of the gravitational field strength between the Earth and the Moon. Basically, whenever it seems like you don't have enough information, the information is found on the reference table. In this case, the mass of the Earth is on the reference table. It's 6.67 times 10 to the minus 11 times our mass of the Earth. Sorry, there's a decimal there. To the 24th times our mass of the Moon. 22, pretty big difference there. Maybe it doesn't look like it. And then the distance between the Earth to the Moon is what we put on the bottom. So a lot of people accidentally put radius here because they see R and they think, okay, I need to put a radius in here. But don't forget, the radius is the path of the Earth going around the Moon. And then finally, don't forget the squared. That's another thing people forget. And we get 1.99 times 10 to the 20. Times 10 to the 20. If you got way off, it's probably, in terms of scientific notation, it's probably a scientific notation mistake. Particularly if you got the same answer. I see a lot of people end up with 1.99, but then their answer is slightly off because they... Right, this is the big one. Make sure that you put parentheses on the bottom. That's the thing that causes a lot of people trouble, is make sure you have the parentheses so it completely divides by the times 10 to the 8th. That's a pretty common mistake I see anytime you have scientific notation. When in doubt, put parentheses around everything. It really just helps make sure you understand the order of operations that the calculator is doing. All right, so we have electromagnetic field. Obviously, we don't know too much about that, but hey, it spins. At the point A, which direction is the net force? Well, if it's in a circle, the net force is a centripetal force, and centripetal means pointing towards the center, which is twice 3, points towards the center. State the direction of the velocity of the airplane the instant the acceleration is southward. Okay, so the acceleration southward, that's when it's at the top. It's accelerating down, which means that the velocity, kind of a weird question, but the velocity then at that point is going over to the right. So it is rightward. Or eastward, you could say. So again, the instant the acceleration is pointing towards the south, it's always pointing towards the center. So when it's pointing down is when the plane's at the top here. And then it's asking which direction is the velocity. Velocity is simply the direction the object is moving. Okay, direction of the velocity of the position shown. Again, it's the direction that's moving. It's going that way. Calculate the magnitude of the centripetal force of the car. All right, so I like to do the combination formula, or I do all the pieces at once, but you can definitely do it in parts, and that's totally fine. The mass, pretty standard car, is 1,500 times the 12. Don't forget the squared. Square is where people often forget things. Divide by the 50. And watch out, after learning gravity, a lot of people really want to square the R too. You're not squaring the R. That's just with the gravitational formula, so be careful with that. And I apologize for not using units. I would have definitely lost points here. I'm just not very comfortable with writing with this thing, and I believe you get 4,320, and we're doing force here, so it's newtons. Yeah, if I was just to finish this off, it'd be kilograms, meters per second, and this of course would be meters. All right, question 12. Question 12 is a little bit of a weird one. This is what I like doing. I like writing the formula out. What we have to think about, the magnitude of the centripetal force object will decrease if. So I have to think each one of these 4 choices is changing one of the values here or changing something that's not important. So one of these values changing is what's going to affect the centripetal force. Nothing else will. So it's just those 3 values. I have to think about which ones are the ones. So speed increased. So if this was to increase, hopefully you see this would increase. Motion is reversed. That's not in the formula, so it doesn't matter. Mass is increased. If this gets bigger, this gets bigger. That makes sense. Radius would increase. If this gets bigger, this will get smaller because it's dividing by it. So it is choice 1. This is a fairly common type of question. And it could be about any formula on the reference table. You kind of have to understand how things affect other things. That's the point of a formula. It's to show you how different values affect different values. It's to show the relationship between values. So sometimes they'll ask it in this word style rather than a number style question. And you have to see if you increase one, how it will affect the other thing. So in this case, if you increase R, it will decrease the centripetal force, which is what it's asking for. All right, this has been me going over this worksheet. Hopefully that has been helpful. Have a good one.